multiplying binomial factors, dealing with binomial factors, it's a little bit more complicated because we have to make sure we're grouping the plus pieces so that we can show them as multiplying pieces, because the x by itself or the 1 by itself, they don't represent factors, but grouped together they represent a multiplying piece. So the difficulty sometimes is that we need to make sure that we are accounting for those pieces. We don't want to say that x cancels x like that. We have to make sure that if we have a binomial factor, that we're using a binomial factor to cancel that out. Okay, so I'm using binomial factor there to cancel out. I need to cancel out the 3, and I have an extra 3 here now, and I need an extra 8 here to make those equivalent fractions. So we must make binomial terms. So we must group, let's just say. We must group binomial terms into factors. Okay, and then we need to be able to use those binomial factors in a times and divide relationship. So non-permissible values. Non-permissible values is basically when we divide by 0. Dividing by 0 is a real problem, okay, because we will learn this a little bit later on, but it actually depends on which side of 0 you're coming on. But basically, dividing by 0, we don't know how many zeros fit into any number. So if I have 3 divided by 0, how many zeros fit into 3? Okay, that's an uncountable number. So we're no longer dealing with numbers anymore, so it becomes a bit of a problem. Later on, we'll see that it actually depends on which side of 0 you come on, because it'll affect the type of infinity that you're dealing with. But for now, we'll just say we can't divide by 0. So if I replace 3 with the x here with a -5, I end up with 3 over -5 plus 5. And that becomes 3 divided by 0. This is a problem. Okay, we can't divide by 0. Okay, so we're just going to try to avoid this. So we're going to say that this is a non-permissible value. So x equals -5 is non-permissible, or a restriction. Okay, so x is non-permissible. So anytime we have a factor that is 0 in the denominator, that will make the whole denominator 0, and that it becomes a non-permissible value. Now the numerator is okay. We can have 0 in the numerator, so here x equals 5 is perfectly okay. But in the denominator here, if x is equal to 0, the whole denominator is equal to 0. Non-permissible. Okay, so there's that restriction. If x is equal to +6, again, we're going to end up with 0 in the denominator, and that's non-permissible. So those are my non-permissible values. In this equation, okay, 0 in the numerator is okay, zeros in the denominator are not okay. So if I look at x plus 1, okay, well, if x is equal to -1, we end up dividing by 0, so we can't let that happen. Here, if x is equal to 1.5 or 3 over 2, okay, we're going to end up with 0 in the denominator again, and that is non-permissible. And the last one here, if x is equal to 0, this is an easy one. 0 squared is 0, non-permissible. We have to have that as a restriction. So these are restricted values, and it's happening because we cannot divide by 0. Okay, we run into real big math problems when we start dividing by 0.